Howdy folks. Today we're going to be talking about algorithms and how to solve them. And this is going to be broken down into a couple different parts. This particular part is going to be on what is an algorithm, how do we kind of understand the algorithm and figure out what it's really asking for, and how do we read prompts. And then some later videos will get into how to actually break down the algorithm and how to solve it. Let's get started. So this is LeetCode. I did another video about LeetCode recently about why it's still important. Companies are not sourcing questions from here as often, but it is still a great place to learn about algorithms, okay? So they have thousands of questions, all algorithm questions. Let's look at one of the easy ones, two-sum. Most people, it's the first question, so a lot of people may have already done this one already, but I want to look at it. We're not going to talk about how to deal with all this stuff right now, like what the code is, sort of thing. I want to look at the side here. Maybe make that a little bit bigger. So this is talking about the actual problem. There's a couple important parts here. One, this is the actual prompt they give you, and a lot of times your algorithms will come as a prompt. A lot of times it won't be as clear what that prompt actually is. The prompt itself may be something you have to figure out based on what your product manager is asking for you, what your ticket has to do. But as you get more familiar with code and more familiar with coding, you'll be able to kind of figure out what the algorithm, what you're being asked to make for your algorithm. But here we actually have an algorithm. Given an array of integers, nums, and an integer target, return indices of two numbers such as they add up to target. This is the big part right here. This is actually what we're trying to do. These are some criteria. You may assume each input has exactly one solution. You may not use the same element twice. Return the answer in any order. This is important because this gives us some constraints, or in this case, some lack of constraints. And that, again, is something that eventually you have to figure out for yourself as you're figuring these out and coming up with your own algorithms. But right now, these tell us specifically each input would have exactly one solution. Why is that useful? Well, it means that once we found a solution, we've probably found the best solution, we can finish, or we're done. So let's look at the second part, which is important, examples. A lot of times, especially during an interview, you have to come up with these yourself. When I interview people, I will give them an example if they ask for it, but I also like them to try to come up with their own examples. This involves you knowing exactly what this algorithm does. So we've got this input, 2, 7, 11, 15. The target is 9. Output 0 and 1. Why? Because 2 plus 7 is 9. Okay. Here, same one, 2 and 4. Target 6. The output is 1 and 2. This is important because this also helps us with edge cases on the algorithm. What do we do if there's two elements of the same element? Well, in this case, you can answer in any order. So 1, 0, 0, 1 would be valid. But that's an important edge case. Here, it's the first two. This one, it's the last ones. We don't have an example of where there's no answer because each input has exactly one solution. We should never actually find some case where there is no solution, which is also kind of useful and also really kind of rare in an algorithm at this point. Constraints, honestly, I don't pay a tremendous amount of attention to these. This is just saying your number, you're going to have up to 2 numbers in the array and no more than 10 to the 4 numbers, which is, what, 1,000, I think? This is the amount, the size, and the target. Sometimes this is useful. I don't often pay a lot of attention to it because, especially in JavaScript, which is what I work in, it's not going to make much of a difference. Like, the algorithm we build is going to kind of run the same regardless. But here's all of your information. Given an array of integers nums, that tells us our input. We kind of already knew that from the example here, but what if we don't have the example? They might actually, another way to rewrite this would be given, you know what, I'm going to pull this back over and just put that in there. So, given an array of integers and an integer target, find the indexes or indices of any two numbers in the array that add up to target. There should only be one such solution. This might be a way I'd see this on... I spelled that terribly. This might be a way I'd see this in an interview. Give an array of integers and integer target. That's important. That tells you what we're starting out with. That's your initial data. Find the indices of any two numbers in the array. Okay, that's that target. This is what we're asked to find. An algorithm is essentially a black box. And for those of you who don't know what black box versus white box, a black box, the idea behind a black box is you don't know what's going on inside. You know, you put something into it, something else comes out. You put something into it, something else comes out. And it should be deterministic. If you put the same thing in multiple times, the same thing should come out. A white box, on the other hand, is something that goes in. You can see what's happening on the inside, and then something that comes out. When I'm writing the algorithm, it is a white box algorithm. I understand exactly what it's doing because I'm writing it. But for someone using this algorithm, it's going to be a black box. They only know what to put in and what comes out. And so as a result, that's all we're really given. Another example of this is someone could come to you and say, hey, we need to display to a teacher the average of all the grades of students in their class. Okay, that's a project. That's a task for you to do. But in that, there's an algorithm. Given an array of integer grades, find the average. So in order to find that average, that's not a very complicated algorithm, but that is still an algorithm. And so that's kind of an example of how you'd have to glean the algorithm from what you're doing and come up with this yourself. Given a list of student data, find the average. Output the average. Then there's additional. There should only be one such solution. A lot of times, these are things that only, as you're building a project, these may only become apparent as you start building the algorithm. But for algorithms like this, we get them right up front. So that's kind of the idea. An algorithm is just a series of steps. A recipe is just an algorithm. They're very important in computer science and programming and web development and all of these things because 90% of what we do is change what data looks like. Even if I'm saying, okay, I have a list of students and I'm looping over those to output React components that display student data. That's an algorithm. Even if it's as simple as take this thing, change it, export another array with the same data. It could be a reduce where you have an array of data and you're turning it into a single item. Those are simple algorithms. And a lot of times in code, we end up writing a lot of simple algorithms, and the larger complex algorithm is just something that's more meta in our minds. We know exactly what we need to do, and we're kind of trying to feel our way through that solution and figure it out. Most of the time, you're not going to actually be writing down, this is the algorithm I need, and then writing the algorithm. It's more likely you're saying, I need to get from A to B. Let me start doing that. And that starts to become second nature. But that's why algorithms testing is so important. And that's why algorithms practice using stuff like this is so important. Because if someone else can come up with an algorithm, give it to you, and you can build it, that means that the only thing you need to do after that is just figure out, how do I come up with my own algorithms based on the tasks I'm trying to do? And that is actually the easier part, believe it or not. So yeah, this is just kind of a primer on just how to read algorithms, look at the important pieces, and generally just some idea of why we care about this. We'll see you in the next one, folks. Have a good one.